Hello everyone, today we are going to present about our project, Blinking LED Control with Arduino Uno. The concept of our project is we want to create a circuit that is not too complicated but also not too easy. We settled for a dynamic LED light that can change the speed of blipping and add the option to increase or decrease the number of LEDs blinking by clicking a switch. Functionalities of our project are adjusting how many LEDs will blip and display the amount on a segment display, increasing the time between each blip, and resetting the delay time back to 1 second. This blinking LED control project allows users to interact with the system and understand how code translates into physical behavior. This project also provides a solid foundation for exploring more complex Arduino applications.
For the circuit, first we'll be using Tinkercad to visualize our circuit. We'll start with an Uno board, a breadboard, and we need a few components such as 3 switches, 4 LED, a 7-segment display, 3 10 kilo ohm resistor, and 11 330 ohm resistor. The first step is to placing the switch. Place our 3 switches on the breadboard. Each switch will be paired with a 10 kilo ohm resistor to ensure that we get a proper signal. The first switch will control the number of blinking LED. Connect the output of this switch to pin 2 on the Uno board. The second switch will control the delay time of blinking LED. Connect its output to pin 1. And the third switch is used to reset the delay time for blinking LED. Connect its output to pin 0 on the Uno board. The third step is to setting up the 7-segment display. This component will show us how many LED are currently on. The 7-segment display are labeled A through G. We will connect each segment to a specific pin on Uno board. Segment A go to pin 3, segment B go to pin 4, segment C go to pin 5, segment D go to pin 6, segment E go to pin 7, segment F go to pin 8, segment G go to pin 9. And don't forget to connect each segment to a 330 ohm resistor to protect the LED in the display. Also, ensure the common cathode is connected to the ground.
Next is the coding part. We start with the setup of our program. Our variables are time, pin number, no LED, which stands for number of LED, and variables representing each segment in 7-segment display. Time is used for creating the delay time. Pin number is used to specify LED range. I is used in for loop. No LED is used as a parameter for 7-segment display function. Next are each segment in a 7-segment display, corresponding to the number of pins they are connected to. A is pin 3, B is pin 4, C is pin 5, D is pin 6, E is pin 7, F is pin 8, G is pin 9. Next, in void setup, we set pin 0, 1, 2 to be input, 10, 11, 12, 13 to be output, initialize I to be 10, pin number to be 10, and time to be 1. Next is the main function of our program. In while loop, we first detect the button presses to adjust the system. In the first if condition, we check the pressing of the leftmost button, which is on pin 2. When pressed, it will increase the number, range, and number of LED by 1. Once it reaches pin number 14, which exceeds the LED limit, it will reset back to starting pin number of 10 and number of LED of 1 LED. The second if condition check the middle button pressing. When pressed, the timer increases by 1. This will be explained later. The third if condition check the rightmost button. When pressed, it will reset the time back to 1. Next part is the beeping of LEDs. There will be 2 for loops with time delay in the middle and at the end. In the first for loop, we use I variable to set the starting index of the loop. Then loop until I is equal to the pin number. Then we use I to be index of LED and set dot index to high. In this way, the LED will light up to the pin number range that we specify by pressing the button. Then, when the time delay, the second loop, we'll set those index back to low. Turning off the LEDs. The delay time is 1000 times the time variable. For instance, The delay is 1000 times 1 equal to 100 microseconds, which is 1 second. In this way, we increase time delay by 1 second each time we press the switch. We also set the number on 7-segment display to display the number of LEDs blinking at the moment. Lastly is our 7-segment display function. The function takes the no LED variable as input and display number on the display accordingly by turning on each segment of the display. For example, if no LED is equal to 1, the segment B and C will light up, displaying number 1. There is also the clear display function to reset the display by turning off all segments of the display.
Here is our circuit on breadboard. As you can see, there is switch, LED, and 7-segment display. The first switch is LED control switch. This switch cycles through a number of blinking LED, ranging from 1 to 4. With each press, the number of active blinking LED increases by 1. As you can see, now there are 2 LED blinking and 7-segment display will update in real time to reflect the current number of blinking LED 2, then 3, and 4. Once it reaches 4, pressing the switch again resets the count back to 1. The second switch is time delay adjustment switch. This switch is used to control delay time of LED blinking. Each press increases the time delay by 1 second, allowing for customized LED blinking interval. And because there is no predefined limit on the time delay, giving user the flexibility to set the delay as desired. And the third one is time delay reset switch. This switch resets the time delay of blinking LED back to the default value, which is 1 second. There you go.